All right, today we're going to talk about what a sequence is. And this is something that is new to us, right? Because it's just a set of terms. It's denoted by a sub n, right? This means sequence. Okay, so, and it has some pattern to it. You probably have did this a couple times in maybe Algebra 2, all right? Where you just have a list of terms, okay? And there's some pattern that goes along with it. Now, the dots are important on the AP. You need to put 3 dots to show that it does continue on, 3 dots to show that it continue on. So that's a weird thing that they want, but they like to have at least 3 dots. If you put 4, it's fine as well, 5, 6, whatever you want to do. N is always going to be a positive integer. So you're never going to have like negative values for n. Another notation that you might see, right, is if it looks like this, it tells you a starting integer, where to start. Okay, and then this would be an infinite sequence because of the infinity. Okay, infinite sequence. If this is not shown, right? If not shown, you always start at 1. Okay? For n, we start at n equals 1. All right, let me show you a couple examples here. So let's say, example 1, if we have something that looks like this. All right, so what you want to do is, since nothing is shown, we're starting at 1, so n is equal to 1. You're plugging in 1, so I'm going to get a negative, and then times 3 to the first, which is just 3 over 1. So this is your first term, a sub 1, which in our case would just equal negative 3. The next term, you're plugging in n to be 2. So negative 1 squared is a positive 1. 3 squared would be 9. Okay, and then you're dividing by 2. Can't really simplify that, so a sub 2 would be 9 halves. If we plug in n to be 3, right, that's going to be a negative. 3 cubed, 27 over 3, and we could simplify that to negative 9. Let's keep going to one more. If we plug in n to be 4, right, you would get a positive 1. 3 to the fourth is 81 over 4. And we can't simplify that. So that's just 81 over 4. So right here, that is our sequence that is represented by that notation. Now remember, this dot means you can continue to do this, all right? Let's look at another example here. Something a little bit different. Maybe they're starting at a different spot. So let's do... say we have 2 to the n, 2n plus 1, and we just want something simple like this. And now here, this is, we start n to be 2. So in this one, you're plugging 2 in first. So 2 plus 1 is 3, so you know you're going to get a negative. Plug in 2 here, so you have 2 times 2 plus 1, right? So 4, 5, so that's negative 5. Now we plug, so this was like a sub 2 because we're plugging in n to be 2 to start. Okay. And then n to be 3, right? If we plug in 3, this is 3 plus 1, so it's a positive 1. 6 plus 1 is 7, right? And you can see it continues the pattern. If we plug in 4, it'll be negative, because 4 plus 1 is 5, that's odd. And then here you get 9. And so on. You know, the next one's going to be 11. And this one, you could kind of see the pattern where it's all alternating odd numbers. When I say alternating, that means it keeps changing the sign, okay? A sub 3, A sub 4, A sub 5, dot, dot, dot. So this is our sequence here where it just continues on forever. Now, what if you had to find the notation in terms of n? All right, so if we have 1/2, 2/3, 3/4, 4/5, dot, 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 and I want to know find the nth term, okay? So the way you would want to start is list what you have. 1/2, 2/3, 3/4, 4/5, right? And if we take a look at this, right, if we look at n to be 1, right, we can see that the numerators, right, are just the same, right, whoops, as our n. Okay, so I know the nth term is going to be just n in the numerator. Now the denominator is a little bit different, but just associate it with that n. So here n is 1, how do I get to 2? N is 2, how do I get to 3? Well, if I do 1 plus 1, if I do 1 plus 2, if I do 1 plus 3, and 1 plus 4, I could get to that 2, 3, 4, 5. So this is going to be 1 plus n, or n plus 1. So you could denote it this way, or you could denote like that. Last one we're going to do is now this one is something that is a popular thing. So the 2, 6, 24, 120 is something that we need to be familiar with, okay? But again, when you're starting this, you got a sub 1 to be 1, a sub 2, 1/2, a sub 3, negative 1 over 24, a sub 4, a sub 4, 1 over, oh, I missed, my bad. Okay, so a sub 1 is 1, a sub 2, 1/2, a sub 3, 1 over 6. Don't forget your negatives. I am screwing that up completely. Sorry, guys. 1, negative 1/2, 1/6, negative 1/24, 1 over 120, dot, dot, dot. Okay, so a sub 1, 1, a sub 2, negative 1/2, a sub 3, 1/6, a sub 4, negative 1/24, and a sub 5 is 1 over 120. So the first thing I want to talk about, if you notice, it alternates from positive to negative. So when you're doing that, we're always going to do like a negative 1 to the n. And in our case, because our first term is positive, we want to make that positive. So either plus or minus 1 is okay. I'm going to do plus 1. If you plug in 1, right, you get 2. So negative 1 squared would be 2. All right, and as you go along, you could see, like, let's rewrite it this way, all right? So that you have them all written as your fractions here. Okay, and with that, now how do we go from 1 to 1, 2 to 2, 3 to 6, 4 to 24, 5 to 120? This is something that we have to be a little familiar with, is called a factorial. So for example, factorial is 5 times 4 times 3 times 2 times 1. So when you're looking at this, it just means that you're multiplying 5, 4, 3, 2, 1. If you do 100, you start from 100 and go down 100, 99, 98, and so on. So you could see that's 1 factorial. So this would be n factorial for our sequence that was given there. So negative 1 to the n plus 1 over n factorial. Thank you.